Welcome back to the Science Channel. Today I have a recently completed school project of mine. This is a circuit, as you've seen from the title of this video, and I made it over the course of 2 months from my engineering class. I really fell in love with the designing and breadboarding of it, and I'd like to share how it works and what it does. Let's get right into it. Now, the first step of how this circuit works is the power source. Nothing in the circuit functions unless power is hooked up to it. The next step of this circuit is the combination of this switch, this diode right here, and this large capacitor and this smaller capacitor. These regulate the electricity flowing from the power source right here. Think about it like this. Everybody knows the band, the Foo Fighters. Now, this right here is the Foo. This is the electricity. This dam are the Foo Fighters. That's the diode, that's the capacitors. They make sure that none of the Foo gets into the society, and the society is the rest of the circuit. Make sure that the circuit won't get damaged from power surges from the power source. Alright, moving on, this is where things start to get a little complicated. This part of the circuit right over here is called the NE555. It's a counter or a clock, and it regulates how fast the circuit runs. This LED right here flashes on or off at the same rate as the circuit runs. This capacitor right here regulates the speed that the circuit runs at. The larger the capacitor, the slower the circuit runs. The smaller the capacitor, the faster it runs. Now you can think about it a little bit like this. There's an old thing called a Greek water clock, and that's really where they had a faucet and it dripped water into a bucket at a certain rate, and after like an hour the bucket would turn over and reset, and that's exactly how the NE555 circuit works. Once the capacitor right here fills up with a certain amount of electricity, it resets, and that tells the LED light to turn on, and that tells the circuit to do whatever it's wired to do. Alright, moving on, these two chips right here and right here control the ones digit on the counter. These chips right here and right here control the tens digit on the counter. These two chips are both called 74LS190s. It's a complicated name, but all these chips do is count in binary. Now these two chips right here, these are 74LS47s. They take the binary from the 190s and convert it into something that these two 7-segment displays can understand. Alright, so the next step in the circuit, the next main visible major part on the circuit are these resistors right here, and the ones up in the NE555 circuit. What resistors do is they resist current. They restrict electrical flow to reduce current, and that's really important when there are sensitive electrical components such as LEDs or 7-segment displays that have LEDs in them. A good way to think about it would kind of be like a valve on a pipe. The tighter the valve is, the less water is allowed to go through it. And kind of like if you have a larger resistor, the less electricity, less current will be able to go through that trace. Now, it may not appear like it, but the front of the circuit is actually the pretty part. If you turn it onto the back side, it's a bit of a mess. I hope you guys can see that okay. It's a much different environment on the back. This is where the electrical current actually flows through. They go through these traces right here. That's where electricity gets from one component to a different component. Our class made these boards from scratch, and I'll throw in some pictures from the etching process and everything that went into making these boards. The back of these boards are copper, which allows the electrical current to flow from component to component a lot easier without a bird's nest of wiring. There had to be holes drilled in the back of these boards so that you could actually fit the pins of the components through and then solder them onto the copper joints. There are many hard parts with making a circuit from scratch, but one of the hardest, there were countless breaks in these traces right here. Now you can kind of see I had soldered some bridges over where the traces had been broken, and that's really important because if there's a single break in this trace, the circuit won't act correctly. Unlike plumbing, where if there's a leaky pipe, it'll still work for the most part. With electricity, or if two traces are connected in a solder bridge, you might short out a component. If you have experience soldering electrical components, you'll know how much of a pain that is. I may have guessed where the purpose of the circuit was going. Well, basically, it'll count up to 99, and with the help of this switch right here, it can count down from 99. It's a little anticlimactic, but it gives you a sense of what goes into today's technology. It's pretty crazy. Alright, thank you all for watching. I hope you learned something new. I'm sorry I haven't done anything in a little over a month. It's been busy. Anyway, thank you so much for 27 subscribers. That's pretty crazy. And yeah, end of video.